Okay, we're going to talk about a new base today, and that is base E. E looks like a variable because it's a letter, but it is truly an irrational number. Its approximate value is about 2.71828128. It comes up a lot in real-world applications in biology, in finance, and things like that. So it's just another base, just like we would have 2 to the x or 10 to the x, we have e to the x. We call it the natural base, and it is, of course, exponential growth because that base is greater than 1. The inverse of e to the x, or its opposite, is the natural logarithm. It is never going to be written the way that you see it there with the log with the base e of x. That's just an example of what we're talking about. Anytime the base is e, then we use ln, the natural log. So ln of x is the logarithm that we use when we have base e. It is always base e. It will never have another base. It will never have base 2. It will never have base 10. It is always base e, and you never write the base. It's just understood that it is there. So what we're going to do first are exactly what we've done with our other bases, going from exponential to logarithmic form and vice versa. It's the exact same process, just because we're using base e, we use the natural log. Now, personally, I write my ln in cursive, just because my 1's and L's look the same. I know some people like to use a capital ln, and that is fine as well, just so that it's clear on your paper that it is the ln and not like 1n. So e to the x equals 24 is the natural log of 24 is equal to x in logarithmic form. Okay, base e, so we automatically use the ln. The natural log of x is equal to 9. Is that exponential form in logarithmic form? And then the last one, base e, so it's automatically the natural log of 72 is equal to x plus 5. So again, it's exactly what we've been doing. We're just using e's and ln's instead of the log and another number. So if we're going from logarithmic form to exponential form, we can still use the swoop. The e is not there. You can write it there. So e to the 58th is equal to x. E to the x is equal to 6. And e to the 32nd is equal to x minus 9. Now, some equations here. Again, nothing has changed. The principles are still the same. We just have a different base and a different log. So right here, e to the x, the exponential is already by itself. So we go to logarithmic form. Natural log of 57 is equal to x. That is our exact answer. For our approximate answer, when we go to the calculator, the ln is beside the 4. Okay, it's beside the 4 on your calculator, ln of 57. Go ahead and store that beside the number 1. Store that as x, because it's not going to be a nice terminating decimal that we can just plug in. Okay, and then we go back to the original equation, e to that value of x, and that should be 57. So that confirms our exact answer and our approximate answer. Okay, in number 20, our exponential is not by itself, so we need to start by getting it by itself by adding 6 to both sides. So we have e to the y plus 3 is equal to 30. Then our exponential is by itself, so we write it in log form. Natural log of 30 is equal to y plus 3. Our variable is not isolated, so we need to subtract that 3. Now, just like our logs last week, you never, ever, ever change what's inside that logarithm. Once it's in there, it is there. So our exact answer is the natural log of 30 minus 3. Now you've got to make sure that when you put this in the calculator that you close your parentheses after the 30 before the minus 3 and store that as x. So y is approximately 0.401. And we can go back to the original, second in the natural log button, x plus 3, close the parentheses, because that's all that's in the exponent, and then minus 6, and that confirms that our answer is the natural log of 30 minus 3, or approximately 0.401. On number 21, our exponential is not by itself. It's being multiplied by 5. So first step is we divide both sides by 5. E to the 4n is equal to 19. Now our exponential is alone, so we put it in log form. The natural log of 19 is equal to 4n. Then we divide both sides by 4 to get n by itself. So the natural log of 19 divided by 4 is our exact answer. Be careful, again, when you put this in the calculator. The natural log of 19, close the parentheses, and then divide by 4. So n is approximately 0.736. Plug it back into the original. 5 times e to the 4x. And that should be 95, and it is. And last one. We've got two things outside of our exponential. We always start with the adding or subtracting if it is there. So 2e to the c minus 9 is equal to 84. Then we divide both sides by 2. So e to the c minus 9 is equal to 42. The exponential is now by itself, so we go to log form. Natural log of 42 is equal to c minus 9. Then we add the 9 to both sides. Again, it does not change what's inside that log. It does not get added to the 42. That's our exact answer. Let's check it one more time. Natural log 42, close the parentheses, plus 9, stored as x, and then plug it back into the original. And we get 87, so it's approximately 12.738.